Well, what do you mean by a compound angle or a multiple angle? What do you mean by a compound angle? If two angles are present in a sum, like a plus b, a minus b, like that, or more than two angles are also possible to be involved in a sum, a plus b plus c, sine of a plus b plus c, cos of a minus b plus c, like that. Those angles are called compound angles, and let us try to rebrush our knowledge regarding the formulae in compound angles. I strongly believe that every one of you is aware of this formulae. Number one, sine of a plus b. What is sine of a plus b? This is sine a cos b plus cos a sine b. Sine of a minus b is sine a cos b minus cos a sine b. Of course, if we can take cos a cos b as a common factor, here you have sine a by cos a, that is tan a. Here sine b by cos b, tan b. You can write sine of a plus b as cos a cos b into tan a plus tan b also. Sine of a minus b as cos a cos b into tan a minus tan b also. Yes. Good. Just like that. Cos of a plus b. What is cos of a plus b? This is nothing but cos a cos b minus sine a sine b. If you can get cos a cos b out, 1 minus sine a cos b by cos a cos b is tan a tan b. Tan a tan b. Just like that, what is cos of a minus b? Cos of a minus b is equal to cos a cos b plus sine a sine b. Sine a sine b. You can get cos a cos b as usual as a common factors to have 1 plus tan a tan b. 1 plus tan a tan b. Isn't it? So, you can be using the result sine of a plus b by cos a cos b, tan a plus tan b. Sine of a minus b by cos a cos b, tan a minus tan b. Cos of a plus b by cos a cos b, 1 minus tan a tan b. Cos of a minus b by cos a cos b, 1 plus tan a tan b. You can have these results. Well done. Again, tan of a plus b. What is tan of a plus b? This is equal to tan a plus tan b by 1 minus tan a tan b. And tan of a minus b is equal to tan a minus tan b by 1 plus tan a tan b. Good. Cot of a plus b. Cot a cot b minus 1 by cot b plus cot a. Well, my dear, you can write as cot a plus cot b also, but there is a very simple benefit we have by writing like this. What is that benefit? Please wait for a minute. I shall mention you after 1 minute. Again, cot of a minus b. What is cot of a minus b? Cot a cot b plus 1 by cot b minus cot a. In order to get it remembered, in order to remember this, let us try to express in both these formulae the denominators starting with cot b. That is the benefit we have by writing like this, cot b plus cot a. Cot b plus cot a. Well, my dear, let us now observe the applications of these. Suppose you have sin theta plus cos theta. This can be taken as root 2 into 1 by root 2 sin theta plus 1 by root 2 cos theta. This is equal to root 2 into sin theta cos 45 plus cos theta sin 45. Sin A cos B plus cos A sin B. What is that? Sin of A plus B. That is sin of theta plus pi by 4. So as and when you have sin theta plus cos theta is equal to root 2 into theta plus pi by sin theta plus cos theta, it can be written as root 2 into sin of theta plus pi by 4. Well, my dear, you can imagine this as sin 45, this is cos 45. Then it becomes cos of theta minus 45. So this is also root 2 into cos of theta minus 45. That is theta minus pi by 4. Cos of theta minus pi by 4. Yes, you can. Isn't it? As this is cos theta cos 45 plus sin theta sin 45. This is cos of theta plus 45. Or this is pi by 4 minus theta you have. Pi by 4 minus theta. Pi by 4 minus theta and pi by 4 plus theta are complementary. That is why sin of theta plus pi by 4 is equal to cos of pi by 4 minus theta or theta minus pi by 4. You see, cos of minus theta is cos theta, isn't it? This can be viewed as cos of pi by 4 minus theta also. Okay. So, if plus sign is here, you can write sin of theta plus pi by 4 or cos of theta minus pi by 4. Both are correct. Suppose you have sin theta minus cos theta. What happens? This will be minus, this will be minus, this will be minus. And then this becomes plus. Isn't it? Like that. This is the matter. Well, you see, knowing the way in which it is used is not just enough. As and when you have sin theta minus cos theta, you must be able to write it immediately as root 2 into sin of theta minus pi by 4 or root 2 into cos of theta plus pi by 4. That is the beautiful usage of this formula, sin of theta plus pi by 4. Well, another beautiful question is before us. Sin x is less than cos x, then x belongs to, he has given certain options, some intervals. Sin x is less than cos x. How can we notice it? Sin x, actually speaking, there has been a graphical explanation also. You may have to draw the two graphs at a stretch on. In one graph, both sin x and cos x must be represented. And you have to trace the region in which sin x lies below cos x. And you trace all of them, and you should prepare a general solution for that also. That is one way. And another way is sin x is less than cos x. Means sin x minus cos x less than 0. That is root 2 into sin of x minus 45 degrees or pi by 4 is less than 0. Am I right? Just now we have noticed it. Sin theta minus cos theta is sin of theta minus pi by 4 into root 2. Do you have any doubt? 1 by root 2 into 1 by root 2 into sin x cos 45 minus cos x sin 45, that is sin of x minus 45. Well, this is less than 0 implies sin of x minus pi by 4 less than 0. Sin of x minus pi by 4 less than 0. Well, where can it be less than 0? Either here or here. Isn't it? You can express it in two ways. In what way? Minus pi less than x less than 0. Or 180 degrees pi less than x less than 2 pi. You can, as you like. Isn't it? So, pi less than x minus pi by 4 less than 2 pi. Okay, x minus pi by 4 less than 2 pi. And this will be true for general solution also. 2n pi plus pi less than x minus pi by 4 less than 2n pi plus 2 pi. You add pi by 4 on both the sides. 2n plus 1 into pi plus pi by 4 less than 2n plus 2 into pi plus pi by 4. Isn't it? 2n pi plus pi is nothing but 2n plus 1 into pi less than x minus pi by 4 less than 2n plus 2 into pi. You add pi by 4 on both the sides. What you will have is 2n plus 1 into pi plus pi by 4 to 2n plus 2 into pi plus pi by 4. This is the, you check all the given options, is it available or not? Or otherwise, you can say one thing. You see, this at this juncture, you can also have minus pi less than x less than 0. Minus pi less than x less than 0. Okay, x minus pi by 4 less than 0. Add 2n pi. 2n pi minus pi less than x minus pi by 4 less than 0. Add pi by 4 on both the sides. 2n minus 1 into pi plus pi by 4 less than x less than 2 pi plus pi by 4. Either this option is correct or this option is correct. What type of similarity can you observe in these two answers, my dear? An odd multiple of pi, next immediate even multiple of pi. Isn't it? Isn't it? An odd multiple of pi plus pi by 4, immediate even multiple of pi plus pi by 4. Here, 2n minus 1 is also an odd number, an odd multiple of pi plus pi by 4. 2 immediate even multiple. What is the even number that which comes exactly immediately after 2n minus 1? It is 2n. 2n pi plus pi by 4. Oh, it is 2n pi. It is not 2 pi. It is 2n pi plus pi by 4. Like that you have the answer. You can check it. Okay, good. So in this also we have used the application. Isn't it? Like that we get the answer for that question. Next one. What happens if the question is sin x greater than cos x? Let us see. Sin x is greater than cos x, then x lies in what interval does x lie? Some 4 options will be given. We may have to check it, which is the suitable option. Look here. Sin x is greater than cos x implies sin x minus cos x is greater than 0, implies root 2 into sin of x minus pi by 4 greater than 0. I think you do agree with it. Implies sin of x minus pi by 4 greater than 0. Sin theta is positive. Therefore, where should it lie? Either in the first quadrant or in the second quadrant. What is theta under consideration? X minus pi by 4. What is theta under consideration? It is x minus pi by 4. Let it be. Sin theta must be greater than 0. What should happen? X should lie between 0 and pi. Am I right? So, 0 less than x minus pi by 4 less than pi. 180 degrees. Good. And to have the general solution, 2n pi less than x minus pi by 4 less than 2n plus 1 into pi. That is pi plus 2n pi is 2n plus 1 into pi. Therefore, 2n pi plus pi by 4 less than x less than 2n plus 1 into pi plus pi by 4. This is the suitable option. Observe this, my dear. an even multiple of pi plus pi by 4, next immediate odd multiple of pi plus pi by 4. It should belong to. That is the interval in which sin x is greater than cos x. Well, my dear, when can sin x is equal to cos x? When can sin x is equal to cos x? It becomes is equal to this. Okay, we shall discuss it in the next moment. When can sin x is equal to cos x? Sin x minus cos x is equal to 0. As before, root 2 into sin of x minus pi by 4 is equal to 0. So that sin of x minus pi by 4 is equal to 0. Okay. While learning something about sin x, we could have drawn the graph of sin x, and from the graph of sin x itself, we could have noticed that the curve meets x-axis at regular intervals of pi 0, pi, 2 pi, 3 pi, 4 pi, and so on to the positive side, minus pi, minus 2 pi, etc. to the negative side. Therefore, sin theta is equal to 0 implies theta is equal to n pi. Therefore, x minus pi by 4 is equal to n pi. Therefore, x is equal to n pi plus pi by 4. And pi plus pi by 4. This can also be taken as 4n plus 1 into pi by 4. I have just taken the LCM, that's all, nothing new in that. So when can sin x is equal to cos x happens? When and only when x is equal to 4n plus 1 into pi by 4 for all n belongs to z. For all n belongs to z. This is the concept. Well, my dear, by making use of sin of a plus b and sin of a minus b, we could have written sin x minus cos x as root 2 into sin of x minus pi by 4. By making use of that, we could have known the intervals in which sin x less than cos x, the interval in which sin x greater than cos x, the interval in which sin x is equal to cos x. This is the most useful information, my dear. Don't forget it. It is very, very important. While dealing with the chapter solution of trigonometric equations, this helps us a lot. X is equal to 4n plus 1 into pi by 4. When can sin x is equal to cos x happen? When x is equal to 4n plus 1 into pi by 4 or n pi plus pi by 4. Isn't it? That's it. This is the uses of those two formulas. And moreover, there are so many usages also for that. There are so many. Let us now observe the formula tan of a plus b is equal to tan a plus tan b by 1 minus tan a tan b. If this is minus, this is minus, this is plus. From this, can you estimate tan of pi by 4 plus theta? So, replace a by pi by 4, replace b by theta. Tan pi by 4 plus tan theta by 1 minus tan pi by 4 is 1 tan theta. Similarly, if I like to have tan of pi by 4 minus theta, then this becomes minus, this becomes plus. What is tan of 45 minus theta? 1 minus tan theta by 1 plus tan theta. What is tan of 45 plus theta? 1 plus tan theta by 1 minus tan theta. That's all. And similarly, what is cot of a plus b? Cot a cot b minus 1 by cot b plus cot a. If this is minus, this is plus, this is minus. Now tell me, what is cot of 45 plus theta? In the place of A, you replace 45, and in the place of B, you let us replace B by theta. What happens? Cot 45, 1 cot theta. Cot beta. Cot B means cot theta plus 1. If you have minus, you have plus here, minus here. These are the applications of this. Good. Then next one. We are to have the value of sine 15, cos 15, like that. What is sine 15? You can write it as 45 minus 30. Sine 45 sine cos 30 minus cos 45 sine 30. Isn't it? Sine 45 sine 30. Sine 45 sine 45 cos 30 minus cos 45 sine 30. 1 by root 2 into root 3 by 2. 1 by root 2 into 1 by 2. Anybody can easily say that it is root 3 minus 1 by 2 root 2. It is a matter of a few seconds only for this derivation. This derivation is not enough actually. It is enough if you can remember the answer. Root 15 is equal to root 3 minus 1 by 2 root 2. At the same time, you will be able to have the value of cos 75 degrees also. Why? 15 degrees and 75 degrees are complementary. Well done. Sine 75 degrees. What is sine 75 degrees? Previously, you have had sine 45 minus 30. Here you should have sine of 45 plus 30 degrees, so that this becomes plus root 3 plus 1 by 2 root 2. And the same can be cos 15. Why? Because 75 degrees and 15 degrees are complementary, So you need not calculate those values. If you can know sine 15, immediately you can have cos 75. If you know sine 75, immediately you can have cos 15 also. Well done, well done, well done. Next one, tan 15. What do you mean by tan 15? Sine 15 by cos 15. That is root 3 minus 1 by root 3 plus 1. Rationalize the denominator. If it goes to the numerator, then it becomes root 3 minus 1 whole square by 2. 3 plus 1 minus 2 root 3 by 2. That is 4 minus 2 root 3 by 2. Hence it is 2 minus root 3. 2 minus root 3. The same can be cot 75 because 15 degrees and 75 degrees are supplementary. Well done, tan 75. What is the matter about it? It will just be reversed. It is, isn't it? Root 3 plus 1 by root 3 minus 1. So that 1 by 2 minus root 3, that is 2 plus root 3. Hence it is cot 15 also. So at a stretch you'll be having two answers. Okay. Isn't it? This is the utility of sine of a plus b cos of a plus b, like that we have. Next one. I like to remove them because all these values are very well known to all of us. Well, I like to have sine 105 degrees. Sine 105 is nothing but sine 75. How? 105 degrees and 75 degrees are supplementary, no? As A and B are supplementary, sine A is equal to sine B. But we know sine 75. What is sine 75? Root 3 plus 1 by 2 root 2. Isn't it? Sine 120, it is sine 60. Next, sine 135. What is sine 135? It is just nothing but sine 45. Isn't it? 135 plus 45 is 180. Hence it is sine 45. Hence it is 1 by root 2. Sine 150 is nothing but sine 30. It is half. And then sine 165. What is sine 165? Sine 165 is nothing but sine 15. Why should you have it like that? Because 165 degrees and 15 degrees are supplementary. Well, what is sine 15? Root 3 minus 1 by 2 root 2. By 2 root 2. Good. Next one. I like to have cos 105 degrees. Cos 105 degrees. Cos 105 degrees is equal to minus cos 75. Why should you have like that? If A and B are supplementary, then cos A plus cos B is equal to 0. Or cos A is equal to minus cos B. Cos 105 is minus cos 75. Cos 75 is nothing but sine 15. So minus of root 3 minus 1 by 2 root 2. What is cos 120? Minus cos 60 minus half. What is cos 135? Cos 135 degrees is equal to minus cos 45. Again, the reason is 135 degrees and 45 degrees are supplementary. Hence, this answer is minus 1 by root 2. And again, what is cos 150? Minus cos 30 minus root 3 by 2. What is cos 165? What is cos 165? Minus cos 15, isn't it? Minus cos 15 is nothing but minus of root 3 plus 1 by 2 root 2. 2 root 2. Well, shall we have the values for tangents of these one? Why not? You can. What is tan 105? Tan 105 degrees is nothing but minus tan 75. Why is it minus tan 75? 105 degrees and 75 degrees are supplementary. Therefore, tan A is equal to minus tan B, isn't it? Well, so this is nothing but minus of 2 plus root 3. Minus of 2 plus root 3. And tan 135. What is tan 135? Minus tan 45. What is minus tan 45? Minus 1. What is tan 165? Minus tan 15. Minus of 2 minus root 3. So far, you are able to have all multiples of 15 up to 180 degrees. 15 degrees, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165 and 180. For all of them you have, isn't it? Well, let us try to get a tabular form of these multiples of 15 so that it might be a good exercise for us to recollect the values on this part. Let us now observe the multiples of 15. You see 30 degrees, 45 degrees, 60 degrees and 90 degrees, they're all already known, so I have not mentioned those angles here. Well, sine theta, cos theta and tan theta. I like to prepare the tabular form. All the values for sine theta, cos theta and tan theta, how can you have? See, filling up of this tabular form is a good exercise of recollecting the values. Come on, what is sine 15 degrees? Root 3 minus 1 by 2 root 2. Sine 15 is equal to cos 75, isn't it? Root 3 minus 1 by 2 root 2. So at a time you can fill two columns. Right. Sine 75 root 3 plus 1 by 2 root 2 is nothing but cos 15, isn't it? Root 3 plus 1 by 2 root 2. Because they are complementary. Well, sine 105. Sine 105 is nothing but sine 75. Why? Because they are supplementary. 75 degrees and 105 degrees are supplementary. Sine A is equal to sine B in that case. Therefore, it is root 3 plus 1 by 2 root 2. Next, sine 120. Sine 120 is equal to sine 60 because 120 and 60 are supplementary. They're supplementary. Therefore, this is root 3 by 2. 135 degrees and 45 degrees are supplementary. Therefore, sine 135 is equal to sine 45. So, it is 1 by root 2. 150 degrees and 30 degrees are supplementary. So, sine 150 degrees is equal to sine 30 degrees. Hence, it is 1 by 2. 165 degrees and 15 degrees are supplementary. Therefore, sine 165 is nothing but sine 15. Hence, it is root 3 minus 1 by 2 root 2. And as you all know, sine 180 is 0. Even 180 degrees and 0 degrees are supplementary. Hence, sine 180 is nothing but sine 0. Hence, it is 0. Good. Come to deal with the values of cosine function. Cos 105 is nothing but minus cos 75. You please recollect. Why? Because 105 degrees and 75 degrees are supplementary. If A and B are supplementary, then cos A is equal to minus cos B. Therefore, this is minus cos 75. Where is cos 75? Just here. Minus of root 3 minus 1 by 2 root 2. 120 is nothing but minus cos 60. Why? 120 and 60 are supplementary. Minus cos 60 is minus 1 by 2. 135 minus cos 45. That is minus 1 by root 2. 150 degrees minus cos 30 degrees with the same logic because 150 degrees and 30 degrees are supplementary. Hence it is minus root 3 by 2. And again 165. You can have cos 165 as minus cos 15. Minus cos 15 means minus of root 3 plus 1 by 2 root 2. Well, cos 180. 180 degrees and 0 degrees are supplementary. So, cos 180 is nothing but minus cos 0. Minus cos 0 means minus 1. Minus 1. Well, now it is our duty to fill the columns, all the columns under tangent row. Come on, tan theta. What is tan 15? 2 minus root 3. What is tan 75? What is tan 75? 2 plus root 3. What is tan 105? 105 is supplementary to 75. So the answer is minus tan 75. That is minus of 2 plus root 3. 120. Hereafter the supplementary concept will be used. 120. What is the supplement of 120? 60. Therefore minus tan 60 minus root 3. 135. Supplement of 135 is 45. So minus tan 45 minus 1. What is the supplement of 150? 30 degrees minus tan 30 minus 1 by root 3. What is the supplement of 165? 15 minus tan 15 minus of 2 minus root 3. What is supplement of 180? 0 minus tan 0 is nothing but 0. Well, of course, this is the beautiful way or pattern of recollecting all the values for these respective angles, 15 degrees, 75 degrees, etc., etc. Well, my dear, those angles, that is 30 degrees, 45 degrees, 60 degrees and 90 degrees, they have been omitted here because they are already known. These formulas create some more formulae also, which are very useful. Let us now observe such things. What is sine of A plus B? Sine A cos B plus cos A sine B. Sine of A minus B sine A cos B minus cos A sine B. Add these two, what happens? These two will be cancelled. 2 sine of A plus B plus sine of A minus B is equal to 2 sine A cos B. And if you subtract them, sine of A minus B minus sine of A minus B, 2 cos A sine B. So, Another packet of information, another quantum of information has been obtained. Sine of a plus b plus sine of a minus b is equal to 2 sine a cos b. Well, from these, let me replace a plus b by some c, a minus b by d. What happens? Sine c plus sine d is equal to a plus b is c, a minus b is d. Add them. A plus 2a is c plus d and 2b is c minus d. Therefore, it is 2 sine c plus d by 2 cos c minus d by 2. Similarly, sine c minus sine d is equal to 2 cos c plus d by 2 into sine c minus d by 2. These formulae have been obtained from these two. Isn't it? So we have learnt about sine function, sine of a plus b plus sine of a minus b and so on, sine c plus sine d and sine c minus sine d. Well, let us have a look towards the cosine function. Cos of a plus b is equal to cos a cos b minus sine a sine b. And cos of a minus b is equal to cos a cos b plus sine a sine b. If you add these two, cos of a plus b plus cos of a minus b is equal to 2 cos a cos b, and cos of a plus b plus minus cos of a minus b is equal to, if you subtract, these two will be cancelled, leaving you minus 2 sine a sine b. Well, this is the new piece of information. As before, if you can replace a plus b by c and a minus b by d, we have cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2, and cos c minus cos d is equal to minus 2 sin c plus d by 2 and sin c minus d by 2. We could have got this formula from these two formulas from component angles. We know that sine of a plus b is equal to sin a cos b plus cos a sin b. Put b is equal to a, what happens? Sin of a plus a, sin 2a is equal to sin a cos a, 2 sin a cos a. Now you replace a by some theta by 2, a is equal to theta by 2, then 2a is theta. Sin theta is equal to 2 sin theta by 2 cos theta by 2. Again, sin 2a is equal to 2 sin a cos a we already have, isn't it? You divide with cos a and multiply with cos a. Anything wrong? Nothing wrong. 2 into sin a by cos a, tan a. Cos a into cos a, cos square a. If it goes to the denominator, secant square a. Secant square a is nothing but 1 plus tan square a. Therefore, sin 2a is equal to 2 tan a by 1 plus tan square a. And here in this formula, put theta by 2 in the place of a. Sin theta is equal to 2 tan theta by 2 by 1 plus tan square theta by 2. Again, in the place of b, you write 2a. What happens? Sin a into cos 2a plus cos a into sin 2a. Isn't it? In the place of b, you have 2a. Isn't it? You can have sin 3a. Later on, we must be able to have cos 2a also. So we have had the formula for sin 2a and sin theta. You can be in a position to write sine theta in terms of tan theta by 2 also. You know, cos of A plus B is cos A cos B minus sine A sine B, isn't it? Put A in the place of B. A plus A is cos 2A. Cos A into cos A, cos square A. Sine A into sine A, sine square A. Put theta by 2 in the place of A. Cos theta is equal to cos square theta by 2 minus sine square theta by 2. Again, cos 2A is equal to, you write cos square A as 1 minus sine square A. So that we have cos 2A is equal to 1 minus 2 sine square A. So, cos theta is equal to 1 minus 2 sine square theta by 2. Also from this, 1 plus cos 2A is equal to 2 sine square A. Well, previously you have written cos square A as 1 minus sine square A. You replace sine square A by 1 minus cos square A, so that we have cos 2A is equal to 2 cos square A minus 1. And if you replace theta by 2 in the place of A, we have cos theta is equal to 2 cos square theta by 2 minus 1. Again, cos 2A is equal to cos square A minus sine square A. Let me divide this with cos square A and multiply with cos square A. What is going to happen? Cos square A by cos square A, sine square A by cos square A. If it goes to the denominator, if cos square A is sent to the denominator, it becomes secant square A, and secant square A is nothing but 1 plus tan square A. Cos 2A is equal to. Again you replace theta by 2 in the place of A, you have cos theta is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. How many? Altogether 4 boxes are there. There are 4 different formulae for cos 2A. One is cos square A minus sine square A, 1 minus 2 sine square A, 2 cos square A minus 1, and 1 minus tan square A, 1 plus tan square A. And in every such thing, you can replace A by some theta by 2, so that you have cos theta is equal to cos square theta by 2 minus sine square theta by 2, cos theta is equal to 1 minus 2 sine square theta by 2, cos theta is equal to 2 cos square theta by 2 minus 1, and cos theta is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. Besides these, there are few more special formulae. What are they? Let us observe. We have cos 2A is equal to 2 cos square A minus 1. From this, try to write cos square A, 1 plus cos 2A by 2. 1 plus cos 2A by 2. You can write. Or even you can have 1 plus cos 2A is equal to 2 cos square A. Again, cos theta is equal to 2 cos square theta by 2 minus 1, isn't it? From this, cos square theta by 2 is equal to 1 plus cos theta by 2. Cos 2 theta is equal to 1 minus 2 sine square theta, isn't it? From this we have sine square theta is equal to 1 minus cos 2 theta by 2. Again, if you write theta by 2 for theta, you have cos theta is equal to 1 minus 2 sine square theta by 2. From this, sine square theta by 2 is equal to 1 minus cos theta by 2. By 2. Yes, these are beautiful formulae which are very much useful in our future. Suppose you want to have sine 9 degrees. You place a is equal to 18 here. Sine square 9 degrees is equal to 1 minus cos 18 by 2. You know what is cos 18. Suppose you want to have sine 7.5 degrees. You take theta is equal to 15 here. I would like to calculate cos 7.5 degrees. You put theta is equal to 15 here. 1 plus cos 15 by 2. Like that, you will be able to have the answer, isn't it? I have given sine square theta by 2 only, but not sine theta by 2. If sine theta by 2 is required, plus or minus root of 1 minus cos theta by 2. If cos theta by 2 is required, plus or minus root of 1 plus cos theta by 2. Like that we have